So let's go back to this idea of a discount or percentage off, and why some of those kind of shortcuts that you might know work. Let's take our 25% off of our $300. And so we can think about this, right, as what we just found was 20, right? We do our 25 hundredths times 300, and we got our $75. And then to find the discount, you do your $300 minus your $75. And then you see that is $225. And you're like, okay, that's not terrible, but it was a couple of steps. So what's another way? What might be more efficient to get at? Can I just see this? Can I jump right to this? How do I get there? And what we can think about is, well, what percentage is 225 of 300? If we were going to simplify this, or if we think about if we take away, right, take away 25%, what's left? Yeah, 75%. So you can think about it as, right, 25% off, or what you have is 75%. And so try that. What is 75% of 300? You can use that same reasoning, 75 hundredths of 300, which would be 75 times 300 over 100. Oops, 75 times 3, right? 300 divided by 100. And now, good, right? 75 and 75 is 150 plus another 75 would be 225. And if you did this division, 225 divided by 300, you would see that that is, sorry, that's, didn't write nicely. That is, right, 75%, 75 hundredths. So this is how we can think about any discount, is as whatever's off, then we can think about what's left. Or, and maybe you're like, that's okay, but I want to see that algebraically. And maybe you're like, no, I don't want to see that algebraically. All right, if you don't want to see that algebraically, you can end the video right here, no problem. But if you want to see it algebraically, I want to bring our attention to this line, right? What we're saying is we have the original, right, our $300 minus our $75, and I'll put it in green, right? Our 75, which is this, right? Our 25% off of our $300. So what you can see here is I replaced this 75 with this squiggle, right? This left side of this equal sign, because they're the same, they're equivalent. So I just replaced it. And now, well, the reverse of the distributive property is factoring. So what you can see is if we pull out a 300 from both here, right, we can factor this out. 300, what's left side is 1 minus 25% or 25 hundredths. And that's the same as 300 times 75%. So no matter what the discount, and if you're always going to then, this is the, sorry, I'm getting ahead of myself, right? This is the discount off. So then you have to do that subtraction to find, right? This is the final price. So if you think about, right, we're taking away this 25%. So we think about what's left. That's exactly what happened here, right? We took away. So what's left? And so that works no matter if it's 25% off, 20% off, 15% off, 36.5% off, right? No matter what, 1 minus that discount will be what's left. So that'll be how you can get your the total or the final price, you know, with the discount. Likewise, it's very similar if you had you know, like a tip you want to add on. So maybe we want to add on, right, 25% onto our $300. So maybe we want to leave like a 25% tip on a $300 bill. Maybe it was outstanding service and we just hit it big at the casino and we are feeling good, right? we have money to spend. So what would, or maybe it's a 25% service fee, right? I don't know if you've probably not, no one's bought tickets online recently, but they have convenience fees that are 12.5% or 25%, right? Really jacks up the price. So we can think about that as the same way, right? Find your 25% of your 300. We now know, right? We've done that enough times now, 75. And then you would do, right, 300 plus 75 to get 375. So we can now look, we can use that exact same line of reasoning. Take this here and replace our 75 with that, right? 300 plus 25% of 300. Now that's the same as 300 times 1 plus 0.25 or 25 hundredths. And these are all equal. And so if you've ever seen that kind of tip or trick for calculating tax, right? You take the total cost price, and then you multiply it by 1.06 for the tax. Has anybody seen that? Well, this is where it comes from, right? This idea, right? It's you're adding it onto. So you have one whole charge, right? You keep that 300 plus we add, sorry, I should do those in different colors. Right, we have our one there, our 300, we have one group of that, and then plus our added, you know, tip, added percent, we'll say, whether that's a tip, a tax, a fee, whatever it is on top, right? On top of that price, that cost, whatever. So, so yeah, so that's the algebra behind it, whether you're adding onto or taking away, you know, as a discount, you can do kind of the, if you like those algebraic shortcuts, I just wanted to share. What I want us to be aware about though, when we're talking about either discounts or fees on top, say you had a 25% off coupon, but then had a 25%, you know, convenience fee. Does that mean, do they, again, what do you want to say, right? They just cancel each other out, right? So you would have, right? It would be net zero. Ah, is that true? Pause it and figure it out. Take a minute. Use an easy number like 100. Is that true? And or does it matter? This is the next question I'm going to pose for you. Does it matter which one comes first? 25% off coupon, then the fee, or do we want to pay the fee first and then do the coupon? Or again, do they just cancel each other out? Doesn't matter. I think you probably tell by the language I'm using, right? That this is why cancel out is so problematic. It's sloppy language. It sounds right. This should work right here, right? But mathematically, that's not true. These are not going to be, you know, undo each other, right? That's what you mean by what the language that you're trying to say is that they, right? These would undo. But are they inverse operations? No, right? So again, problematic. This is why if you're talking about it undoing each other, then they're going to be inverses. But we can use that sloppy language, and then what we're going to do is foster misconceptions, because students aren't going to make sense of, well, when does it work? When does it not work? Why is it not true? Right. So this is why attending to precision, right? Math practice number 6 is so important, especially in our language. Not only as teachers, but also for our students. So that way they can make sense of what's going on and why we do what we do. So let's check this out. So let's do $100. We'll do both cases. So what we're buying something for $100. We're going to first take off coupon and then add fee. So let's try that. That'll be our first one, and then we'll do it the other way, right? We'll do fee first, then coupon. And go ahead, pause it now, try both of them, and then you can watch the video and see, if what you did matches to what we're going to do now. All right, so let's do it. So we can use a shortcut. Do you want to use a shortcut of, we know if we're going to do 100 minus, right, 25% off, it's the same as just saying 75% of 100. And again, I'm using 100 just so the numbers are quick. Use any number, use a calculator, make sure it works all the time and that you understand where these numbers are coming from, right? So I should have done like color coding. All right, so first we'll do the coupon in the green. So we'll do 100 minus our coupon. So we have 100 minus 25, or again, which is the same as just 75% of, right? This is 75. And now we'll do add the fee. So our fee is going to be 25%. But what is it 25% of? Is it back at the 100? No, it's the fee is on now our current price, which is only $75. So now we'll have, 75 times 25 plus 75, right? Or again, if you want to use the shortcut of 1 times or 1 and 2500th times 75, go for that, right? So now this is where we want it, and maybe see, look, now the numbers aren't so great. What's 25% of 75? And you're like, I don't know. And so this is where you can think of this as 75 divided by 4. Or if you want, especially for now, we're just illustrating. Use your calculator. We can think about this. It comes out to 18 and 75/100ths plus 75. And so, add up 93 and 75/100ths. So see if we, this is coupon. This is our fee. So we see that we didn't bring us back to 100. And actually the coupon, right, even with that 25% convenience fee, we're still less than $100. So we have a little bit of a discount, right? We still saved almost $7, $6.25, right? So this off and then on, right? If you take a percentage off and then you add a new percentage, right? It's the reason why it changed is because right here, right? We're now doing our fee is on our new price, our $75, not our original $100. So that's really important. So go ahead, let's try number 2. What do you think? Is it going to be exactly the same? Yes? No? how can you think about it? How can you reason about it? Okay, we'll do fee first is in blue. So we'll do fee first. So we have our 100 times 25 plus 100, right? Or again, if you like it to think about it as just 100 times 1 and 25 hundredths, that's also fine. But if that's also looks more confusing to you, either way works, right? These two are equal, meaning they mean the exact same thing. That's what the equal sign means. So, well, and maybe you don't like it this way. So think about it as, 25% of 100 is 25 and then plus 100. So this is 125. Nice. And maybe you saw that, right? And again, maybe we see this shifting of place values right here, right? Here's our decimal point, but I'm going to move the 2 over, not one place, but 2 places, right? This 2 in the tenths will now be in the tens, right? It moves to the ones and then to the tens. The 5 in the hundredths moves to the tenths, then to the ones, right? The numbers moved, not the decimal point. Awesome. And so all of these kind of this is how we see, right? Making these connections is that fluency and flexibility that I've been, preaching since day one of the class. And maybe you're getting sick of me saying that. But now check this out. If we did the fee first, right? Our fees in blue, what happens? What's going to be our coupon? Are we going to take 25% off 100? No, we're going to take 25% off. Oops, sorry, what am I writing? Of 125. So we have 125 times 25%. Oops. Minus 125 times 25%, right? Or now we want the 75% of the 125. So now what's that? Again, you can think about it as 125 divided by 4. Since 125 is not a multiple of 4, that's not really that much more helpful. But 125, 25% of that is 31 and 25 hundredths. And then 125 minus 31 and 25 hundredths. Oh, what do you think? Ooh, ends up being exactly the same. So think about that now. If the order didn't matter, or if these are the same, does that mean the order doesn't matter? Fee first and then the coupon. Or we did the coupon first and then the fee. And then can you explain why? Right? Because we see our fee in this case, right, was only $18.75, but our fee in this case was $25 whole dollars. However, our discount here, right, was $25 whole dollars, but then our discount here, right, was 25% of, right, our discount here was greater. So they ended up being the same in the end. So the order doesn't matter if you do one first, then the other, but in no way, right, do those undo each other, right? Even though they're the same percentages, it doesn't ever bring you back to the original $100 for whatever it is, because of this, right? The fee, because either the discount is then on a bigger number, like here. Oopsie, I erased something. Right, the discount's on a bigger number. Oh, goodness, my discount on 125, right? Because the price increased because of the fee, or in this case, the fee, right, was on the $75 and not the $100. So it was a smaller fee.